Hey guys, Brian Schultz here with the Actually Tiny House project, where we are exploring smart, simple, sustainable tiny house design and giving you some building tips along the way. Now, the topic of today's video is tiny house electrical systems, and this is the second video in a series that I'm doing. In the first video, I talked about how to size electrical service for a tiny house in general, and in this video, I'm going to show you how we brought the electrical service into our tiny house and also give you a tour of our service panel here. But before I do any of that, I want to make it super clear that I am not a licensed electrician. I've done a ton of electrical work over the years, residential systems, off-grid, marine, and RV. So I feel like I know what I'm talking about, but that doesn't make me an expert. And you shouldn't take this as official advice. You should always have a licensed electrician check your work, even if you have some experience, because all it takes is one small mistake to create a life-threatening safety hazard. Electrical safety for yourself and everyone that will ever use the system that you wire is your responsibility. All right, so I think the best way to walk you through this system here is just to start with the service connection at the front of the trailer. Now, there's obviously lots of different ways you can wire up a tiny house service connection. What we're doing here is going with a surface mount 240 volt 50 amp standard RV box. Now, the reason I like to go with a surface mount box instead of a flush mount box is because it allows you to open it up later and get to the wiring inside if you want to change out your plug or you want to wire it for a different electric configuration. The reason that I decided to go with an RV plug here is because it's just kind of a good standard connection for a mobile dwelling, and it has components that are designed to go with it. So if you ever happen to be in some place where they have standard RV power, you're going to already be adapted for that. Now, the 50 amp plug here is 2 hot legs, a neutral, and a grounding plate off to the side here. So this is a 240 volt configuration. But the cool thing about this is it can be switched over to a 120 volt configuration with an adapter, but there's something really important that you need to know if you're going to use an RV adapter. And this gets into one of those areas where there's a unique danger to tiny house people who might be more familiar with household electric, but are not familiar with RV electric and are trying to mix the components together. The way that RVs are wired, even if they're wired with a 240 volt box like this, is they're always coming to 120 volt loads on the inside of the panel. And that's important because if you have a 240 volt load on the inside of a panel and you plug in a 120 volt adapter that has an internal jumper in it, that jumper just connected these 2 hot legs right here into a single 120 volt leg. And if those are now going into the opposite legs of your bus bar, and then you're trying to feed a 240 volt appliance off that, you have just basically taken electricity that's meant to oscillate back and forth like this, and you've forced it right into both sides of that. It is a super dangerous thing to do, and this is a mistake that even electricians have made before and created, serious problems with. So if you're going to use an RV box like this, and you're going to use one of these 240 volt plugs, and you're going to use one of those adapters to bring it down to 120 volt, if you're somewhere where there's only 120 volt, you cannot have any 240 volt loads in your sub panel. You have to either cap off those loads, disconnect them, or rewire them to run on 120 volts. That is a super important thing to know about this. All right, so now that we've talked about this box, let's head over to the panel. I'll show you how everything is wired in there. All right, so next let's talk about the service panel. What this is 125 amp Eaton sub panel. And there's some things I really like about this panel and one thing that I really hate. What I like about this panel is that it's just a really good size. It's got 8 spaces that uses the most common style of household electrical breaker. It can be rewired in a variety of different configurations, just like any sub panel. Overall, it's just a really good overall size. It's not too big, it's not too small. The thing that I really don't like about this sub panel is that the grounding bar, which is something that you have to buy separately, is located in the worst possible place. So if you're wiring up any sub panel, you have to maintain separation between your ground and your neutral all the way back to the main service panel, which means you have to install this grounding bar. But if you install this in this location, which is the only rated location in this particular sub panel, it is impossible to get in here and tighten these screws once you have any of these breakers in place. So I think that's a huge flaw in this particular box, but overall, I like the configuration so much that we decided to go with it anyways. So that is the service panel. Now let's actually talk about the electricity that's coming into it. All right, so what I've got here is 6'3" cable that's coming in through a 3/4 inch strain relief. One side of the hot is going into one bus bar, one side of the hot is going into the other. You've got the neutral going to neutral, and the ground is going to ground. And this is kind of a good setup because, like I just said, if you're using a standard 50 amp RV plug, you can switch this between 50 amp 240 and 30 amp 120 with an adapter as long as you only have 120 volt loads on the inside of the panel. Now, my panel here is actually an exception to that. I do have a dedicated 240 volt load, which means that I can never use one of those 30 amp RV adapters on the front of that plug unless I go ahead and rewire this into a different configuration. Now, if you were going with a standard 30 amp RV plug that doesn't have 240 on it, then what you would do is you would just pull one of your hots into one of these bus bars here, and then you would use a jumper to come over to the other bus bar. But if you want to do this completely up to code, you would either have to do a Y-splice or you would have to get a lug that's designed to accept 2 wires to go into this one right here. And now, just a word on wire size here. You might want to pull large wire into your panel even if you're just going with a standard 30 amp 120, because if you ever want to upgrade things in the future, or if you want to make any changes, well, it's way easier to have this wire in place rather than to have to excavate your walls and, run new wire. Now, the only downside of that is 6'3" wire is a lot more expensive and it is a lot harder to work with than 10'2" or 8'2". So that's just something else you might want to think about when you're deciding whether it makes sense. Now, another thing you might want to think about here, if you're planning on adding any type of an off-grid setup in the future, is just bringing your service line in a convenient location so you can add either a grid-tied inverter or a transfer switch without having to do major surgery inside your walls. And even though I'm not showing it right here, if you leave a little bit more slack than this in this loop, you'll be able to do a splice somewhere in this area into that equipment without having to pull your service all the way out of your box. So that's something to think about as well. So now let's just talk about the individual circuits here. What I've got is this 240 volt 30 amp circuit here, and this is feeding my water heater. And the only reason that I have this crazy big circuit for this water heater, which is incidentally the only reason I have all this heavy duty electrical service, is, like I said before, because we have a big water heater tank to act as a reservoir for our solar and wood-fired hot water system, and it only made sense just to use those elements as our backup electric power, which meant we needed to upsize the entire panel. If I didn't have this particular scenario, I would just run a small tanked but switched hot water heater off of one of these 20 amp small appliance circuits or its own separate 20 amp circuit. And that would allow me to bring this whole panel down to a 30 amp 110 setup. Now, a mistake that I'm just catching right now while I'm talking about this is that I forgot to label the white wire here on this 240 volt circuit. Anytime you're running standard 2-wire like this, 240, you have to label the white wire black on both ends to signal that this is also a hot conductor. So imagining that this is not here, you could think of this as just a 30 amp 110 panel over here, and we've got 4 different circuits. All right, really quick lesson here in electrical circuit protection. On any electrical circuit, you have 4 different potential types of protection. You've got overcurrent protection, which is your circuit breaker, which is designed to trip anytime you try to pull more electricity than is rated through that circuit breaker and wire combination. And that's mostly concerned with just not overheating your wire, melting it, and causing a fire. Now, the next kind of protection is your ground wire right here. And what this does is it provides an alternate path for electricity if there's a fault between your hot wire and a device that you're using. So if you touch it, the electricity will travel through the copper wire instead of through your body and into the ground. Now, the third type of protection is ground fault circuit protection. And these are the little boxes that you commonly see in kitchens. And what those do is they monitor the difference between the hot wire here and the neutral wire here. And if there's a little bit of a difference in current, they'll immediately shut down and protect you from getting electrocuted. And the reason you see those in kitchens and on outdoor outlets is because those places have a much better conduction path to ground, either through water or metal piping or just standing on the ground itself. So the potential electrocution hazard really goes up in that situation. Now, in addition to those little boxes, you can also get the ones that fit into a circuit breaker. And when the circuit breaker ones first came out, they weren't very reliable, but that was a long time ago. So if you get on the internet and you read a bunch of cranky old men talking about how you shouldn't use the circuit breaker ones, that doesn't really apply anymore. They're pretty reliable as long as your system is set up correctly. Now, the final kind of protection is something that's more recently required by code, and that is ArcFault circuit interruption. And what an ArcFault circuit interrupter is it's a specialized breaker that fits into your service panel that detects a break in your hot wire that might be sparking and could potentially cause a fire. It also detects any potential arcs between the hot wire and the neutral wire. And these are now required by code on all of the receptacles in a living area. And I think they are especially important for tiny house builders because tiny houses could be potentially prone to a ton of vibration while they're traveling down the road, which means the chance of loosening a connection and having an arc fault just goes up exponentially. Now, ArcFault circuit breakers are hugely expensive, and if you get the combination ArcFault dual function ground fault circuit breakers, they can be upwards of $50 a pop. But when you consider how few circuits are in a tiny house, that's just an extra $150 for a huge amount of extra life safety. And more to the point, even though there is not an inspecting legal body for tiny houses right now, that doesn't mean that we shouldn't be wiring things to code anyways. So just a quick word on language here, because this is a little bit confusing. If you're buying combination ArcFault circuit breakers, it's important to understand that combination ArcFault circuit breaker doesn't mean that it's a combined GFCI AFCI. Combination in this case just means it can detect series or parallel arcs. If you're looking for a combined AFCI GFCI, what you need to get is a dual purpose AFCI GFCI circuit breaker. So it's kind of confusing, but it's an important distinction. All right, so back to our electrical loads here. We've got the first breaker. This is a 30 amp normal breaker. It's going to end up being a 20 amp breaker, and that's going to feed my outdoor outlet that is actually just going to have a GFCI outlet on it because that's the simplest and the cheapest way to do this. I'm not worried about ArcFault in this case because it's a dedicated run. It only has a connection at the box and a connection here, so that's a pretty minimal chance of creating arc faults. Now, coming down here, this is the first of two small appliance circuits. These are both 20 amp circuits that are coming to the middle of the trailer and are going to feed the kitchen counters. One circuit goes above the counters, one circuit goes below the counters, and this allows us to split any high loads like tea kettles or hot plates or ovens in a way where we can have a couple of those happening in the same location at once without tripping one of these breakers. You could also potentially pull a tankless hot water heater or a small tanked switchable hot water heater off of one of these, or you could do a separate 20 amp circuit for that as well. These are dual function combination AFCI GFCIs here, and these are pretty expensive, but it takes care of your AFCI, your GFCI all in one place. And then people know that if you have a trip, they can just come back right to this main panel right in the middle of the house and then flip it. It just makes it easier to understand the electrical service for anyone who might not be familiar with that particular house. Now, coming down here to my last circuit here, this is just a 50 amp regular household circuit. We're running some lights, we're running our outlets off of it, and this is just a combination EAFCI. It doesn't have a GFCI integrated into it because it's not going to be in a wet area or near any metal or any water. So I feel like AFCI is just enough protection for this, and this is also what code would require for this type of a circuit. All right, so now let's actually just look at some of the little wiring details, because how you wire up a box like this not only makes it easier to use, but it also makes it a lot safer. All right, so coming into my box here, I've got a couple of electrical wires. Any wires coming into the box need to be stapled within 12 inches of the box. I actually just rewired this, so I pulled my staples here, but what you want to see is these wires stapled separately. Now, coming into the box itself, before you get there, it's really important to label where these wires are going. This is super helpful for future electricians and your future self who might forget where things are going. Now, actually heading into the box, you need to go through an approved strain relief. And there's 3 different kinds of these, and only one of these do I really actually like. So if you look in my hand here, the first one of these is The kind that has a screw on like this. You can see this screw here. This is the kind you want to use. It's way easier to work with, and it's nice because you can back it out if you need to and get rid of it if you want to change your mind and plug this hole. Now, the other kind that looks very similar just pops into place. And this is the kind you don't want, because if you pop one of these in and you change your mind, these are a bitch to get out of there. So I would recommend going with the screw kind. Now, the last kind of these is just this little plastic guy right here. And these actually have one advantage, and that is you can split them apart and you can put them around a wire like this. And they're kind of handy for that, because then you can just push it in like that if you forget to put a strain relief in while you're wiring up your box. But the big downside of these is they lock really hard onto the Romex right here, and if you need to get a little more slack on your wire or pull it one direction or another, it's really hard to do because you can't back these out. So I'm a big fan of this first kind of strain relief right here. Okay, so heading up into the inside of the box here, I like to label each of my wires inside the box as well. But if you're going to do this, you have to do it in a really specific way, because code requires you to strip the sheathing off the cable inside the electrical box. So these bits of sheath that you see here are actually pieces that I labeled and then slid back over the hot wire only. And that is an okay thing to do. It's also really nice because the future you that might not have remembered exactly what you did has a really quick reference when you open the box. Ideally, you should have a wiring diagram sitting right here on the box permanently attached, but in real life those things tend to get lost or they get painted over, and having labels inside the box is a really nice reality check if you go to redo your wiring. So just a really quick word here about stripping the sheath off inside of your service panel. The way that the pros do this is they'll score this with a razor knife like this and then pull the sheath off. But I would recommend against that, because unless you are really good at it, it's really easy to nick the interior wire. And if you accidentally nick that wire, you're not allowed to fix it with electrical tape. You have to pull this out and put a new wire in. Another way that you might be tempted to do this is just with a combination tool like this. And these are fantastic for making up electrical outlets, but they're actually pretty bad for stripping the sheath off inside of a service panel, because if you try to use that tool at an angle, it's also really easy to nick the wire on the inside. So as a non-professional electrician, I think your best bet is just to go with something like this. This is called a cable ripper. It goes over the wire like this, and then it clamps down and pierces it, and it slices the sheath without slicing any of the interior wires. And then you can just go ahead and pull the sheath back, pull the paper off of your neutral, or your ground, I mean, and then you can just go ahead and cut off any of this excess, and you've got good stripped cables without risking cutting your wire on the inside. Now, next thing that's important is to run your wires really cleanly inside of here, and also to leave a little bit of extra wire in case you need to rewire your box. And incidentally, this is not my cleanest work, because I have already rewired this box when I changed my mind between 30 amp 110 and 50 amp 240 here. But because I followed my own advice and I ran my wires a little bit long, it was easy for me to change over the breaker locations that I needed to. And there's different ways to do this. The way that I like to do it is just to follow the outside of the box really tightly and come in at a right angle to the breaker. But I've seen some electricians that come up, like I've done with this wire right here, and just leave a loop coming back down, which might be an even better idea. Leaves you extra length inside of your box, which gives you more choices, although you do have to be careful to make sure it's nice and neat. The reason it's so important to do good, clean work like this is because it makes it a lot safer to work on, because you can see what's going on and there's less chance that you're going to miswire something and make a mistake. Now, another thing that's really important while you're wiring is to think about your sequencing, because if you just start pulling wires in here indiscriminately and hooking them up to whatever breaker you want to hook up first, you're going to find really quick that you back yourself into a corner that makes it very hard to hook up successive breakers, and also makes the inside of the box really messy. So you want to think really carefully about where your wires are coming from and where they're going to, and then develop a sequencing strategy that's going to allow you to make these connections really cleanly and easily. So just in case you're wondering, these curly white wires here are the neutral wire that's coming off of the ArcFault circuit breaker. In an ArcFault circuit breaker, the neutral wire goes into the breaker, which is going to monitor that current, and then it comes out through a pigtail wire and into your neutral bar right there. And this is an important reason that you want to do clean work, because once you start getting these wires and the pigtails involved back here, things can get pretty crowded and pretty messy if you're not careful. Now, just another thing to be cognizant of while you're wiring up a panel is to make sure that any ground wires are tucked really tightly out of the way, and also that any hot wires that are coming into your circuit breaker are stripped only exactly as long as they need to be to fit into the breaker. Because what you don't want to do is create a situation where you've got some bare copper coming out of the circuit breaker and possibly the bare copper from your ground contacting it. And I can see right here on my breaker that I've got a little bit of copper showing on this conductor, and I've also got this ground here, which is just kind of sloppily sitting right here. This is probably not something an inspector would call you on, but way better habit to tuck this out of the way a lot more tightly and also recut that so it's perfectly fitting into the circuit breaker. All right, so a couple final bits of advice for wiring up your service panel here. I would recommend getting some of these little metal plugs so you can plug up any knockouts that you accidentally open up that you decide not to use. I would also recommend taking the screws that go into the front of the panel here and putting them in a little plastic bag and stapling them to the studs, because otherwise you're gonna lose them and then they're not gonna be there when you go to close up your electrical panel. You should also make sure that you get in here with a screwdriver and tighten everything down nice and tight before you close it up. And you should also do that anytime you move the tiny house, because a little bit of road vibration could potentially loosen some of these connections in here and create a safety hazard. So make sure you tighten everything down nice and tight before you plug your trailer back in. Final thing, you want to make sure that you actually know what you're doing before you undertake any kind of electrical wire. A small structure like this may seem like it's not a big deal, but it carries all the same hazards and all the same responsibilities as wiring a full-size house. So if you don't know what you're doing, don't do your own electrical work. And if you only kind of know what you're doing, I would highly recommend that you get some of these code check books here. These are great, they're inexpensive. They tell you how to keep all of your electrical work up to code and give you some illustrations of how things are wired correctly. You should also get a licensed electrician to check your work when you're done to make sure that you haven't created any safety hazards. All right, I think that's it for wiring up the service panel here. I'm sure there's tons of stuff I forgot. So once again, don't just take my advice. Make sure you check with a variety of sources. Another really good video here on YouTube is from Tiny Nest, and that's Jake and Kiva. Jake is a professional electrician, and he's got a great video for wiring up a service panel as well. If you have any comments or any feedback, make sure you leave that in the comments down below. I'm always open to ideas for how to do things smarter, how to do things safer. If you want to follow more of what we do here, you can check us out at our website, which is actuallytiny.com, or you could follow us on Instagram, where we post a daily build blog of everything that we're doing here, including time-lapse videos of all of our work, including the electrical work that you see right here. All right, that's it for now. Take care. Be safe building your tiny house.